Welcome back. We are on day 2. We're going to use Venn diagrams to show relationships for events. Okay. First thing we need to talk about is mutually exclusive events. And mutually exclusive events are events that have no overlap. For an example, flipping a coin. The coin either lands on heads or tails. There's no overlap, right? I can't land on heads and tails at the same time. Okay. So that's why these circles are separate. There's no overlap, which you wouldn't see in a typical Venn diagram like that you would see in English class, okay? So remember in English class where you say, here's the common parts and here's what's just in this story and just in this story? So that's what we're talking about with Venn diagrams. We can use them in math too. So when rolling a die, the outcome is 1, 2, 3, 4, 5, 6, as we've talked about. None of these can occur at the same time. But if we look at specific events, so if we look at event E, that's rolling an even number. So I'm just going to write even over here in this circle. Okay, and event F is the event of rolling a number greater than 3. Oh, just greater than, not equal to, sorry. Right? So I want to go through all of my options, and what I'm going to do is I'll start with the number 1. Well, 1 is not greater than 3, and it's not even. Okay, so that's not going to go in either circle. So if I think about all my even ones, I have 2, which is not greater than 3, so that's not going to go in the other circles. 3 is not even, and it's not greater than 3. 4 is even, but it's greater than 3, so it's going to go in this common part here, because it's both even and greater than 3. 5 is not even, but it is greater than 3, so we're going to put it here. And then 6 is even and greater than 3, so it's going to go in the center. Now, what's interesting is we are going to draw a box around our circles here, because we want to show all of our sample space. So I have the numbers 2, 4, 5, and 6 taken care of, but 1 and 3 don't fall into either of these categories. So what I'm going to do is I'm going to write that on the outside of my circles, but inside my square. So all of my sample space is included in this chart, but it's not in the overlapping circles at all. So again, this is all the even numbers, so 2, 4, 6 are all even. These are all the numbers that are greater than 3, 4, 5, 6. And this center part is just what's in common with even and greater than 3. Okay? Alright, let's try another one. So we're going to put this data in a Venn diagram. So there are 10 cards, each printed with the number 16 to 25. So what I'm going to do is I'm just going to write 16 to 25 here. So we have 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25, just so we know our full sample space, okay? So let's draw our Venn diagram here. So I'm going to draw my 2 overlapping circles, and I'm going to label this one A and this one B. And what I'm going to do is I'm going to look at this, and I'm going to say, okay, are there any numbers in common with A and B? And they're not. So all I'm going to do is write 18, 21, and 24 in this circle, and 20 and 25 in this circle. Notice there is nothing in the middle here. So I actually could have drawn these circles apart if I had seen that before I drew my circles. Now, I'm going to write all of the numbers that are not included in these 2 circles on the outside here. And it can go anywhere on the outside of this chart. Okay, so I'm just going to go through my numbers that I wrote for my sample space. So 16 is not included in either, so I'm just going to write that here. 17 not included, so it's going to be here. 18 is included, 19 is not. 20 is, 21 is, 22 is not. 23 is not. 24 is, and 25 is. Okay? So now I kind of have a rough idea of what's going on with my data. Okay? And then it asks me, what's the probability of A and what's the probability of B? So the probability of A, I know there's 3 choices for A. Okay? Out of how many? I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 in my sample space. So I have 3 out of 10, or 30%. Okay? And for part B, I have 2 out of 10, because there's 2 numbers inside of my circle out of 10 total. So if I multiply that, that would be 20%. Now, if I said, what's maybe the probability of C, and C is everything outside here, that would be out of 10, 1, 2, 3, 4, 5 numbers, which would be 50%. Now, conveniently, if I add all these up, 30 plus 20 plus 50, that's 100%. Like they said in the video, we need to make sure all of our probabilities add up to 100%. But technically, we didn't have to find this one. So just know if you only find parts of the percentages, it's not going to add up to 100 like that, okay? But once you find all of them, it should add up to 100. Otherwise, you either missed something or added something extra. Okay, let's move on. So, we have a name is randomly chosen from a list of names. So we have Bill, Jesse, Eva, Chloe, Mary, Ruth, Kim, Henry, Elsa, and Sean. So let X be the event of choosing a name with 2 vowels, and let Y be the event of choosing a name made up of 3 letters. So what I'm going to do is I am going to write down X and Y up here, just so I have all their names in the right box. So X is choosing a name with 2 vowels. So Bill doesn't have 2 vowels, Jesse does. Chloe does, and I believe that is a little typo there. Okay, oh, Eva also does. I missed Eva. We're going to say Y is not a vowel. Okay, so we're not going to include Mary. Ruth does not. Kim does not. Henry does not because he has a Y. Elsa does. And Sean. Okay, and Y is 3 letters, I believe, right? Okay, which Bill, Jesse, Eva includes in there. Okay, Ruth, Kim, and I believe that's it. So what I'm going to do is I'm going to say, what's the same between the two? Well, the only name in common with these is Eva. So Eva gets to go right down the middle here. Okay, so then I'm going to have Jesse, if I label this one X, Chloe, not going to include Eva because she's already included, Elsa, and Sean. Okay, and then the only one going in my Y circle is Kim here by itself because Eva's already in my Y circle in the center here. And then I want to make sure I include anyone else I didn't include on the outside. So we're going to have Bill, Jesse, Eva, Chloe, Mary. Ruth is not included here. And I believe Henry is my last one here. Just to make sure I got all my names, I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 names. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I did include all my names. The first question, are X and Y mutually exclusive? Well, mutually exclusive means there's no overlap. And in this case, they are not. And why is that? Because of Eva. Okay? But if we look back on our last one that we did, these two would be mutually exclusive, A and B, because there's nothing in the middle here. Okay? Now they want me to find the probability of X. Well, we just added up that there's 10 total names. So the probability of X is 4 out of 10. And the probability of Y is, I'm sorry, it's not 4 out of 10. You have to include this double right here. Okay? So in X, there's actually 5 names. Okay, which will reduce to 1/2. The probability of Y is 2 out of 10. Okay, because again, Eva is in both of them. So it might even be helpful to look back up here at your sample space to kind of help you decide how many are in each one. Okay, which we can reduce that either to a fraction or change it to a percentage. So this would be 1/5. Okay. Again, these don't add up to 100% because we're not including these, and Eva's in both, so that kind of throws off our numbers a little bit. Okay, so go ahead, pause this video and try the exit slip. So it says A is a letter selected at random from the state name Rhode Island. Let C be the event of getting a consonant, and let H be the event of getting a letter that comes after H in the alphabet. Draw a Venn diagram to show the events. So again, I'm going to say, all right, H, okay, is the event of getting a letter after H, and C is getting a consonant. So I know R is a consonant, H is a consonant, D is, E is not, I is not, S, L, N. Now D is in here twice, so I'm going to just write a 2 under my D. Okay, and let C be the event of getting a consonant, let H be the event of getting a letter after H. So R is after H is not after H, O is after H, D is not, E is not, H, I is, S, I, J, K, L is, A, N is also. Okay, so the first thing I'm going to do is when I draw my Venn diagram, I'm going to see when I label this H and C, is there any overlap? Okay, and there's an overlap in R, there's an overlap in S, L, and N. So we're going to have R, S, L, and N. And then we're going to have O, I in this circle, and H and D in this circle. And then are there any letters we didn't include? So we have R, H, O, D. E is not in either one, so we're going to have an E out here. I is included, S is included, L, A is not included, so A is going to go out here. N and D are included. Okay, so this includes all my letters. There is a double D, so sometimes we'll just write a 2 next to it just so we remember that there's 2 of them. If we needed to find the probability of getting just the letter D, we would need to make sure that we understand that that's a possibility. Or even if we were calculating out the probability of the event C happening. Okay? Hopefully this helps.